Hello friends, in last lecture we have discussed objectives of testing. Testing is required to be done for different reasons. For selection of raw material, process control, development of process, product testing, specification test and for research. After understanding significance of testing the textile material, let us start with the first unit, that is sampling in textiles. So, the learning objectives of this session are to understand needs of sampling, to learn various terms and definitions in relation to sampling, to study factors affecting sampling and to learn selection of sample. Friends, here you can see 4 different pictures. Let us assume you have to test these different materials for different properties. In first case, a box has been shown containing thousands of equal weight silver coins. In second case, wooden tables have been shown having same dimensions. Third picture shows 4 mangoes. In fourth picture, a container has been shown with thousands of mangoes. Now let us assume you are going to report about weight of silver coin from first box. You have to report length of the wooden table from second picture. You have to report about test of mango from third and fourth case. What will be your steps? Just think on it. Think for a while. You can write the answer in your notebook. Fine. So, as far as the first case is concerned, where there is a box containing equal weight silver coins. As you can see here, there are several coins, but these coins are man-made, developed by or prepared by same mold. So they have same properties. Ultimately, if you are asked to report about the weight, you can collect simply single coin out of it and you can report weight of, you can report it as weight of the coin, right? In second picture, all the tables have same dimensions and therefore it is not at all necessary to measure length of each and every table. You can have measurement for only one table, since again it is man-made, designed to specific dimension, and therefore if you measure length of single table, it will be enough. In third case, mangoes are there. Now if you are asked to report about test of the mangoes, what you can do is, you can test all the 4 mangoes, isn't it? Because there are only 4 mangoes, you can have it and you can report about the test. But remember, here you are going to destruct all the 4 mangoes. In fourth case, there is a container with thousands of mangoes, and now if you are asked to report about the test, if you go on testing each and every mango, nobody is going to allow you, even if you can, right? And therefore this may not be solution for this. The case here is these are natural materials. They contain lot of variations. And next thing, you cannot test each and every individual. And therefore, what is solution for this? You have to select sample. Thus, the process of selection of sample all or representative from given bulk is called as sampling. Thus, sampling is defined as a process of selection of representative from the given bulk. When it comes to textiles, textile material contain lot of variations. It may be fiber, yarn or even fabric. Fibers, they differ in almost all the properties. They differ in terms of length, diameter, strength, etc. Even it is not possible to have positive control on each and every fiber while we process them. And therefore, when you convert the fibers into yarn, you have to accept certain variation. When you convert such material into fabric, again you have to accept certain variation. And with such variations, it is impossible to test each and every individual from the population. So, what are the reasons why it is not possible for textile materials to test each and every individual? First is, textile is a system of mass production. To test each and every individual is time consuming process. And third thing, even if you decide to go for testing of every individual, then few tests are destructive in nature. For example, if you decide to test each and every meter of fabric for its strength, you will be destroying whole roll of the fabric. So it is not at all advisable. So sampling is essential step in textiles. Let us study few terms which are used in sampling. The first term is population. Population is bulk available for testing. Like over here, I have shown three different cases. First is a go down containing number of bells, a single bell, or it can be few grams of cotton fibers. Now here the size of bulk is different. Here it is number of bells, here it is one bell, well here it is few grams of cotton. Now whatever may be size of the bulk, this bulk which is available for testing is called as population. So if a go down containing number of bells is available with you for testing, your population is these number of bells. If only one bell is there with you, the population is single bell. If only say 200 grams cotton is there with you, the population is 200 grams of cotton. So in general, population is defined as bulk available for testing. There are two types of populations. One is called as heterogeneous population and second is called as homogeneous population. As has been shown in this picture, the main difference between these two is distribution of the individuals. In both the samples, both the population, variations are there. But then if you just observe here, the two types of variations, those are concentrated in different zones. There is as such no mixing of these variations. Well, over here variations are there, but then these are distributed uniformly. So homogeneous population is one where individuals are distributed uniformly, while heterogeneous population is one where the individuals are distributed non-uniformly. Let us go for the next definition. Sample. A sample is relatively a small fraction which is selected to represent a population. Now, what exactly is the sample, meaning of the sample? We have discussed about the population in previous slide. From the population, since it is very difficult to test each and every individual, you have to select small fraction or small portion which represents whole bulk, whole population. Say for example, from your class, you have to report about the height of the students and the class strength is say 200 number of students and we have limited time. Then instead of measuring height of each and every student, what we can do is we can zone wise divide the students. Select one student from each zone, measure the height and find out the average. That can be the average height of your class. So selection of few students from different zone, that group of student is called as sample. Understood? Now here also let us consider one example from textiles. While you select sample, you must be very careful. Like if you go wrong in selection of sample, then everything will go wrong. Your testing will go wrong, results will go wrong, and then your process, the objectives of the testing may not meet. And therefore, the very first step you have to do is correct selection or appropriate selection of the sample. Let us understand this with the help of this example. Here is a cotton bale weighing 500 pounds. If you convert it into milligrams, it will be 500 into 453.6 into 1000, which comes to 226800000 milligrams. Now, as per the standard procedures, you need to select a sample having size of 20 milligram. So, from this much weight or this much population, you just have to collect 20 milligram. So, what is the portion you are collecting? 113,40000 of the population. So, this 20 milligram is going to represent this much of the population, and hence it is very essential to be careful while you select sample from the given population. The next definition is random sample. As we have discussed in previous step, a sample should be true representative. So, random sample is a true representative of population where every individual in the population has an equal chance of being included in the sample. So, this green is a sample, a population, and if you want to get true representative, you can go for collection of sample from various zones. I have shown here by red color. So, without giving importance to any of the factor, if you collect sample from different zones randomly, it will be true representative, and hence it is called as random sample. The next definition is biased sample. Unlike random sample, if you give importance to specific factor while you select the sample, then the resultant is biased sample. Biased sample is thus defined as a sample in which selection of an individual is influenced by factors other than chance and the sample ceases to be true representative of the bulk. There are three different causes in general for a biased sample. The first cause is physical characteristics of the individual. Here I have shown a plate on which fibers are there, fibers having different lengths. Now if you are asked to report about length of the fiber and you are going to collect few fibers from the given bulk, then what is easy for you, like collection of short fibers or longer fibers? Obviously it is very easy to collect long fibers and measure length of those fibers. It is bit difficult to collect short fibers using a forceps and measure length of these fibers. So while you test the material, while you collect the sample, you may give importance to longer length fibers, and this biasing is physical, due to physical characteristics of the individual. So this is first cause of biased sample. Here I have shown few cheeses stored in different layers. This is the population, right? Now if we have to test strength of the population or this yarn, then a person may select sample or from upper layer of the population. He may not collect sample which is there present at bottom layers. So here this is also biasing because of the position of the material. So this is second cause because of which biased sample results. As has been shown in this third picture, this is a container containing different ring bobbins. Those are differing in terms of colors. As far as yarn is concerned, they have same material. Now if we want to check strength of the yarn and we have to collect 10 bobbins out of this. Now let us assume that your favorite color is red. Then what you can do is, you can give importance, your subconscious nature will force you to collect red color bobbins. Like here you will give importance to red color bobbins, and out of 10 maximum number of bobbins may be of red color. So here unknowingly you are giving importance to specific factor. Thus this is a bias because of subconscious nature of the person. After biasing or biased sample, let us move to the next definition, length biased sample. As has been discussed in previous slide, if you give importance to longer length fibers, then the resultant sample is called as length biased sample. This is specific towards textile materials. In few cases, the fiber may not be straight to the axis. For example, a card web. In card web, the condition of fibers may be like this. Few fibers are like this. Those are hooked at one end or at both the ends, and then available length, that is available length parallel to the axis, is only this much. Well, the true length is this. Now this is called as actual length, well this is extent of the fiber. While you select sample, if you give importance to the fibers having more extent, then the sample is called as extent biased sample. Thus it is defined as a sample in which the chance of fiber being selected and included in sample is proportional to its extent. Obviously, The longer fibers, they have greater extent, and therefore extent bias sample will have a bias towards obviously longer fibers. Next definition is numerical sample. Numerical sample is a sample in which all the fibers in the population have an equal chance of being represented in the sample. Let me explain this in detail. Like suppose this is population, and you know that there are exactly 4 million long length fibers. There are exactly 10 million medium length fibers and 1 million short length fibers. While you select sample, suppose you have selected 4 long as to 10 medium as to 1 short. For example, 40 long fibers, 100 medium, 10 short, to make them 150. Then this sample is called as numerical sample because you have collected the sample according to their proportion, according to their number. So here there is no chance of error. This numerical sample will have zero error. Now, as per definition, if you just see the definition, it is a sample in which all the fibers in the population have an equal chance of being represented. Now, this is same as that of random sample. But what is main difference? As far as random sample is concerned, since you are selecting sample randomly, it may contain random error. But such error is not there in numerical. Numerical sample will have zero error. Of course, practically such perfection is highly impossible, and therefore a random sample with its corresponding random error is the type of sample which we have to normally accept or operate with. So these are different terms and definitions in relation to sampling. So friends, today you have learned needs of sampling in textiles. Why we have to select sample in textile materials. Then we have discussed various terms used in relation to sampling. Here is an activity for you. Based on today's learning, you have to write the answer for the question, what is need of sampling in textiles? And second, try to recall various terms we have discussed today and try to write definition of all these terms. You can start the activity now. Start writing in your notebook. Try to complete the activity in next 5 minutes. Thank you. Thank you very much for your attention. Now you can join the session on Teams. If you have any doubts related to today's topic, you can ask the questions unmuting yourself, or you can write your questions on chat box. Now you can join the live session again and we'll continue the discussion. Thank you.